Hi guys, this video is all about the volume of a rectangular prism. So a rectangular prism is just this shape that we see here. Sometimes it's also called a cuboid, and it's a three-dimensional shape. So when we talk about the volume of an object, we're talking about the amount of space that an object occupies, and we measure this in cubic units. So if you take a look at this here, this block, I guess, is a cuboid that is 1 centimeter cubed. So 1 centimeter cubed. Okay, so now if we take a look at this bigger cuboid, we can see that it is got a length of 4 centimeters, a width of 3 centimeters, and a height of 5 centimeters. So if we wanted to work out the volume, we'd look at like how many centimeters cubed do we have, or how many of these little cubes have we got in this object. So we can obviously just count them separately. So we could do it a little bit quicker though by saying, well, we've got 4 by 3, so 4 by 3. That would give us like sort of one layer, one let's say flat rectangle, and then we've got 5 of those. So we've got 4 times 3 is 12. So if you take a look at one sort of layer of the cuboid, that would be 12 centimeters cubed, but we've actually got 5 layers here, so we would have to do 12 times 5, which is 60. Okay, so the total volume of that would just be 60 centimeters cubed. And that's basically how you work out the volume of any rectangular prism. You're always going to do the length times the width times the height. So you're just multiplying the 3 dimensions together. Okay, so just a quick example to start. If we wanted to find the volume of this rectangular prism, all we need to do then is multiply the length times the width times the height. So 2 times 5 times 4, which gives us a total volume of 40 centimeters cubed. Now, one thing that you need to remember is, or you need to just notice, I guess, is it doesn't really matter which one is the length, the width, or the height. It doesn't matter which order you multiply them, because remember, you can multiply numbers in any order. So if you had done 4 times 2 times 5, that would have given you the same answer. So as long as you're multiplying the 3 different dimensions together. Okay, let's take a look at a second example. This one is written in words, so let's just have a read through. One side of a rectangular prism has an area of 25 centimeters cubed. If the total volume of that prism is 200 centimeters cubed, what is its height? Okay, so if we take a look here, what this is saying is that if we draw, I'll just draw myself, sorry, you have to mind my drawing, it's not very good. Okay, but here we've got a rectangular prism, and I'm saying one side of it, so let's just say this side here, has an area of 25 centimeters squared. Now it's asking for the height, so we need to know sort of what this other dimension is. But we know the volume is 200. Okay, so that's the sort of diagram of this picture here. Now, although we don't know the length of each side, we know that this area here is 25 centimeters squared, and so it doesn't really matter what the length and the width is. We know that when we multiply them together, we get 25 centimeters squared. So that volume is just going to be the length times the width, which is 25, times the height, and that's going to equal 200. Sorry, I'll make that so that it equals the volume that we've been given, which is 200. So to work out the height, all we have to do is divide 200 by 25. And that will give us a height of 8. We're working in centimeters, of 8 centimeters. So basically, another way to think about the volume of a prism is you're actually just taking, because you're doing length times width times height, length times width is just the area of one face, and then you're timesing it by the height. Okay, so here we've got a shape that is made up of 2 different cuboids. So to find the volume of the entire figure, we're going to have to look at the volume of the cuboids separately and then add them together. So we'll call this one volume 1 and we'll call this one volume 2. So volume 1 is just 6 times 7 times 1, length times width times height. which is 42 centimeters cubed. Sorry, that's volume 1. And then volume 2 is, let's see here, we've got length times width, 3 times 4. And then times the height, which is the same as this length here, so 7. So that means the total volume is going to be 3 times 4, which is 12, times another 7, which is 84 centimeters cubed. And if we add those together, we'll get the total volume of that shape. So the total volume would be 42 plus 84, which is 126 centimeters cubed. Okay, so in this example here, what we've got is we've got a wooden block that has a square hole cut through it. So this little hole here, that's the hole, and it goes all the way through. So we want to know what the volume of the block is. So to work this out, what we'll have to do is first find the volume of the big block of wood as if it didn't have a hole cut in it. Okay, so that's the volume. We'll call that volume 1 of this big cuboid. So that would be 5 by 5 times the height, which is 8. So that would be 200 centimeters cubed. And then what we're going to do is calculate the volume of that hole that's been cut out. Okay, and that one is 2 by 2, and it's got the same length because it runs the whole way through. So 2 by 2 by 8, which is 32 centimeters cubed. So the volume, the total volume of that wooden block would be 200 minus, because we've got a hole cut out of it, so 200 minus 32, which would give 168 centimeters cubed. Okay, so the last thing we just need to look at is the difference between volume and capacity. So volume is really, when we measure and we talk about volume, we're talking about a solid amount. So like say you were like, I don't know, filling concrete or looking at a brick, maybe that would be like the amount of volume in that 3D object. But we also can measure capacity, which is measuring basically like a liquid. So if you had a can of Coke that's measured in milliliters, you might have like 350 milliliters. So capacity, when we talk about capacity, we're talking about basically the volume of a liquid or a gas. Okay, and the common metric units for capacity are liters and milliliters. So in 1 liter, we have 1,000 milliliters. Okay, and then there are a couple of other units that are less common, but we still need to know them. So a kiloliter, 1 kiloliter is 1,000 liters, and 1 megaliter, okay, and that's a capital M and a capital L. 1 megaliter is 1,000 kiloliters. Okay, so those are the basic conversions we need to know. And you can convert between volume and capacity, and that's a really simple conversion. And it's just that 1 centimeter cubed, so the volume, is equal to 1 milliliter. Okay, and similarly, 1 meter cubed is equal to 1,000 liters, or 1 kiloliter. Okay, so just to finish up, you've got a couple of summary questions. The first, I'd like you to try and draw 2 different rectangular prisms that have a volume of 72 cubic units. And the second is, I want you to convert between centimeters cubed and meters cubed. And we did this when we were looking at area conversions, but you might want to draw yourself and say, okay, well, a cube that is 1 meter by 1 meter by 1 meter, that's got a volume of 1 meter cubed. If I drew that same cube but in centimeters, how many centimeters cubed would I have? Okay, so you can use that to start you off. And then you can go on to some of the questions from chapter 11H.